Hi guys, so in this video today we're going to be exploring some electron configurations. So first things first, you're going to make sure that you have your periodic table ready to go. Okay, very important tool for doing electron configurations. The next thing you'll want to keep in mind is the notes that we've taken, specifically this page of the notes that I gave to you with the orbital filling sequence, okay, that shows us the lowest energy orbitals to the highest energy orbitals. So to get started, I'm going to put my periodic table there. Let's go over the steps for writing electron configurations. So the first thing we should do is count the total number of electrons that we have. Note that for right now, these are neutral, so the number of electrons will be equal to the number of protons. Okay, so after we do that, we're going to fill the lowest energy level first. Always start with 1s. Then we're only going to partner up our electrons if we need to. You will need to, but sometimes you won't. Okay, and then make sure that your partnered electrons have opposite spins. And that's really important for your orbital filling diagrams when you're actually drawing the arrows. So here's our first example that we have. So we have magnesium. Okay, so Mg. And I know that magnesium has 12 electrons. And I know this because I used my periodic table. Magnesium's atomic number is 12. That means it has 12 protons, so therefore it must have 12 electrons. Okay? So, looking back here at our increasing energy, we're always going to start with 1s. Now remember, s orbitals can hold a maximum of 2 electrons. Okay? Then we're going to go to 2s, which again can hold a maximum of 2 electrons. After that, we're going to go up to 2p, which has 3 different orbitals. Each orbital can hold 2, so we have 6 electrons being accounted for in our 2p. And then finally, that's going to bring us up to our 3s, which will hold the final 2 electrons. So this is a really handy tool. Another way we could think about this is with our actual periodic table. So let me make sure you can see this. Looking at magnesium, we know that this is the S block, okay? And we know that because if we look over to the left, it says 3s. So we're on the third energy level in the S block. So this is where we're going to have to end, okay? So again, start with the lowest energy level. So we have 1s for hydrogen, and then we're going to go all the way over to helium for our second element in our S block. So we have 1s, 1, 2. Okay, so the first thing I'm going to write is 1s2. Then after helium is lithium. So we are now in the 2s energy level and block, and we have 1, 2 electrons. So 2s2 is next. Then we're going to go over in a straight line from 4 to 5. Now we're in the 2p, and we're going to count every single box. So 2p, 1, 2, 3, 4, 5, 6. So we have 2p6. Okay. So far we have 2, 4, plus 6. We have 10 electrons accounted for with this electron configuration. So we need 2 more. So we're going to go from neon, number 10, all the way to sodium, which is number 11. And that will bring us to the 3s energy level and orbital or block. And we have 1, 2, and that gets us to magnesium. So 3s2. So this is the final answer. This is our final configuration. Okay, a great way to check this is to add up the superscripts. So 2 plus 2 gets you 4. 4 plus 6 gets you 10. And then 10 plus 2 gets you 12. We have 12 electrons and we have accounted for all of them. So this is a correct answer. Let's try some more. So I have 3 on this paper, but we'll take them one at a time. So again, periodic table, super handy. Also, this diagram, this chart, your best friend, okay? So we're going to start with aluminum. So looking at aluminum on our periodic table, we know that it has 13 electrons. So we're always going to start with our lowest energy level. So again, we're going to start with the 1s. In other words, always start with hydrogen and just count the boxes until you get to your desired element, okay? So we're going to have a 1s2. That will bring us to helium, okay? Then we're going to go down to lithium, which is in the 2, or the second energy level in the S block. So we have 2s12, 2s2. And we're going to keep going all the way over to number 5 for boron. So we have 2p6. We haven't made it to aluminum yet, so we're going to keep going. We're back at sodium, so 3s12. And finally, we're going to keep going over to the 3p, and the first square is our desired element. So we're going to have 3p1. Okay, so again, we have 13 electrons to account for. So 2 plus 2 is 4, plus 6 is 10. 10 plus 2 is 12, plus 1 is 13. Okay, so that is the electron configuration we're looking for. All right, let's do another one. Let's look at zinc. Okay, so what do we always start with? Thinking internally. 1s. Okay, so we're going to start with 1s2. That will then bring us to 2s2. Then we're going to go to 2p6, 3s2, and then back, referring to my periodic table, we've made it to 3s2, so we're going to go to the 3p. So we're going to have 1, 2, 3, 4, 5, 6. So 3p6, and that brings us to argon, which is not zinc, so we need to keep going. We're going to continue on to potassium, which is in the 4s. So 4s12. And this is where you need to be careful. You're going to follow in a straight line, okay? So we go from 4s to 3d. Okay, let me show you on this. We're going on our merry way from 4s to 3d. 3d is after 4s, but before 4p. Okay, it's just based on their energy. So we need to go to zinc. So we're in 3d. We're going to count all the way over to zinc, which will get us 3d. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3d10. Okay, so this one's a little bit longer, but the pattern, the process stays the same. Again, to check this, you have, Miss Stone made a fatal mistake, you guys. She didn't determine her total number of electrons first. So, good thing I'm double checking my work. So we have 30 total electrons. So let's see if we've accounted for 30 electrons. So we have 2 and 2, which gets us 4. 4 and 6 gets us 10. So then we have 2 plus 6 plus 2, which is 10. So we got a 10 plus a 10 plus a 10. Bam. Trace 10s, so that's a 30. Last one more. I know, you're like, Miss Stone, stop talking. I can't, guys, I can't. So the first thing we should do is count our total number of electrons. So iodine has, unfortunately, 53. Buckle down, buckle up, I don't know. Just get ready, okay? So we're always going to start with the lowest energy level, meaning 1s. Here we go. 1s2. You should be able to do this in your sleep by now. Always start with 1s2, okay? So 1s2, 2s2, 2p6. After 2p, we go to 3s. 3s2, 3p6. Okay? Now, this is where we got to be a little careful. After 3p, from argon to potassium, we go to 4s. So 4s, 1, 2. After the 4s, 3d. And we know that's going to be a 3d10. So after 3d is 4p. We're going to include all 6 of those. So 4p6. After 4p, so 36 to 37, we go to 5s. 5s, 1, 2. After 5s, 4d. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4d10. And then after 4d, we go back to 5. So we're in 5p and we're counting until iodine. So 1, 2, 3, 4, 5. So it's going to be 5p5. And yes, that's a really long one. But there's a shortcut that we will shortly learn. We need to learn the hard way first, and then we'll learn the shortcut. Okay, so those are just a few examples of electron configurations. Hopefully that helps.